Okay, part B. Drawing this out again. We've got 0.5. You've got 40 degrees. You've got the tension going off at an angle of 20 degrees. There's the tension. You've got the normal reaction. And then you've got the weight dragging it down like that is 0.5 G. Okay, so componentalizing the force, the tension, should I say, we've got a bit going like that and a bit going like that. And might as well draw it on. We've got the weight doing a bit like that and a bit like that. So write the components on. We know this is 20 degrees here, so I know this is going to be T, and it is cos 20, and the bit going up here is going to be T, and it is going to be sin 20. This is 40 degrees, and I know the bit going down here is 0.5 G, and it is cos 40, and the bit going down here is 0.5 G, and it is sin 40. So all I've got to do now is the same process, okay, and that is to resolve perpendicularly, and we'll say up is positive, the net forces is equal to 0, and I end up with R plus T sin 20 minus the opposing force, which is 0.5 G, and it is cos 40. We know that that is equal to 0. Throwing it over, you end up with R equals 0.5 G cos 40 minus T sin 20, and that leads us therefore to F max, and we know that mu, coefficient of friction, is a fifth, so I know that that's going to be a fifth of 0.5 G cos 40 minus T sin 20. So coming across here now, I'm going to resolve parallel to the plane. We'll say up is positive. Okay, using again net forces is equal to 0. Looking at the diagram, I haven't put F max on. F max, it's about to move down the plane, so F max will oppose motion, and it is F max because we're in limiting equilibrium. So now I've got 2 going up, so that is T cos 20 plus F max minus the opposing one, which is the weight component, which is 0.5 G, and it is sin 40 is equal to 0. Substituting in with F max as that, you've got T cos 20 plus a fifth of 0.5 G, and it is cos 40 minus T sin 20 minus the 0.5 G, and it is sin 40, and we know that all of that is equal to 0. Now I'm going to factorize, expand out and factorize the T. So T open brackets cos 20, that times that is a negative, and that is 0.2 times by that, so 0.2 with the T removed is sin 20 equals, that gets thrown over, is 0.5 G, and it is sin 40, and that times that is 0.1 G to positive, becomes a negative 0.1 G, and it is cos 40. Okay, so therefore T equals 0.5 G sin 40 minus 0.1 G, and it is cos 40, and that is all over, and I've got cos 20 minus 0.2 sin 20. So T is equal to, I've done it on the calculator earlier, okay, plugged it all in, gives us 2.75 newtons to 3 SF. Okay, I hope that makes sense.